Hello, everybody in China. Unfortunately, I cannot be there, but I hope I can and you can get the presentation through the video, and we have hopefully also a discussion. The topic I'm talking about today is the car of the future, a data center on wheels. Roland Berger is supporting various OEMs in strategic and transformational challenges in their way to the software-defined car. And from that and our work also with automotive suppliers, we are developing a lot of knowledge in that space, which we compiled in a kind of study to show what's going on and what's the future of automotive electronics and software. Uh, the content I'm going to speak is about changing ecosystems that require OEMs and Tier 1 suppliers to redefine their strategy. There's a paradigm shift in the EE architecture. I will first talk about leading OEMs that will move to zonal EE architectures by 2025, and that leads to a full commoditization of computing hardware. I will then talk about future software platforms and the CarOS, and last but not least about new competitive dynamics that result from that, because Semcos and tech players threaten the traditional Tier 1 position and push also in the profit pools that are occupied by OEMs alone so far. Let me start with the first topic. Consumers expect a seamless journey integrating features across devices and the cloud. For example, social media and social media data that needs to be integrated in the car. Mobile is the primary center of connected mobility, and car platforms need to be compatible to multiple platforms. Therefore, the car of tomorrow will be a software-enabled cloud-connected data center on wheels, and the architecture of the software will be somehow similar. So we do have a core functionality that is provided through services and cross-domain software architectures. There might be a monetization of software as a service as well as third-party applications, a decoupled hardware and software life cycles, and a standardization of software architectures. Currently, we have a distributed architecture that is characterized through 80 to 100 separated monofunctional ECUs that are proprietary, bundled together with software by Tier 1 suppliers. We do have multiple standards for communication protocols and middleware. We have complex cross-domain feature implementation and therefore a lot of complexity that needs to be reduced. Automotive companies therefore move toward a more centralized architecture. In a first step, that will be domain centralization. So, for example, domains like infotainment and instrument cluster telematics functionality in one big computer. Hardware will be based on 4 to 5 custom engineered domain controllers that are being produced by Tier 1s, but at the same time, first large automotive SoCs will be in the market, for example, by companies like Huawei. Infotainment in the Western world is dominated by Android Automotive, in China by the BAT companies Baidu, Alibaba, and Tencent. On the left side, you see a graphical representation of the domain controller projects that are currently being requested by OEMs in the West. In the future, with real volumes in 10 years from now, we will see so-called zonal architectures. Zonal architecture means we do have a bundling of functions into mission-critical and non-mission critical partitions, and a redundant central vehicle computer for mission-critical cars. There's a full consolidation and commoditization of systems-on-chip-based computing hardware expected that will start in the next year, and the car is basically treated like a data center. All these computing platforms, are connected through Ethernet and are therefore treated like a data center where software can seamlessly switch between different computes. The speed at which this transition is executed strongly depends on the OEMs, and some forerunners already move to domain centralization now. That's being done, for example, by Volkswagen with their E3 platform. They launched that first time with the ID.3, but also with other companies. Let me talk about now about the future software platforms and the car OS. What do we mean OS? Basically, it's this gray thing in the middle. It consists of the operating system and abstraction layers like containers or hypervisors, as well as certain middleware software for connectivity and the backend. In addition, we do have other software stacks coming up from the top. We have the middleware and software framework. We have application enablement and functional stacks, for example, for the infotainment sector that is, as I said, currently dominated by Android in the West, but also by companies like Alibaba or Tencent in China. We do have other stacks, functional stacks, for example, for ADAS. This is the mission critical part. Here, companies like NVIDIA already start to enter that market as a semiconductor company. The same is true for Huawei. Huawei also develops not only the hardware, but also the software stacks for fully automated driving. Back-end platforms typically are dominated by the large tech companies. The Alibaba Group and Tencent in China, specifically Amazon, with Amazon Web Services and Microsoft, the Western world. We do see in the future corporations of tech companies and tier ones as the most likely providers of future software platforms. Why? Because that could combine tier one automotive integration capabilities with the capabilities of the tech companies in the cloud and provide software and scale. There's a possibility that there are partnerships of OEMs to provide these type of software, but we see that as less likely. As you can see on the right, there are a couple of opinions we collected from OEMs and tech companies. For example, a collaboration of a major OEM in this area together with a tech company, with other OEMs, would be quickly on the radar of EU antitrust authorities. So cooperation between OEMs not really likely. Now, to what leads this all? To what leads this change in the market? A centralization of the hardware towards custom engineered domain controllers first, and then towards basically commoditized ECUs that are based on systems on chips. Systems on chips developed by companies like Qualcomm or NVIDIA, or even by the OEMs, as we have seen it recently with Tesla. On top of that, a layer that is basically a software hardware abstraction, similar to the platforms, the cloud platforms provided by companies such as Huawei, such as Amazon or Microsoft, that will abstract the hardware level and allow to put functional software on top. In these functional softwares, since the software need to be maintained for quite some time, we expect software platforms that can be maintained in agile processes to dominate, and simple applications on top that basically create the differentiation for the OEMs. Let's go a little bit deeper. In the past, we had basically the tier ones covering all those software stacks. So they did provide the hardware based on semiconductors together with the software, for example, for ADAS automated driving or for infotainment. Complete systems as provided by companies such as Neusoft in China, for example. The OEMs did define some specific customer features on their own, but basically it was the business of the tier ones. But that business, as you can see from this graphical representation, is threatened from various companies. It's threatened by the semiconductor players in light blue. They provide computing hardware, they provide systems on chips, which basically reduce the value add of the electronic suppliers. It's threatened by the technology players. Technology players like Tencent, Baidu, Alibaba, like Microsoft, like Amazon. They provide already complete platforms like the Microsoft Connected Vehicle platform, or platforms from other companies like Alibaba, that integrate also customer specific features, and most importantly, that are connected to back-end platforms that allow the user to log in. As I said, in the Western world, there's specifically for infotainment Android Automotive together with Google applications, automotive services. And then we do have specialized software suppliers that pick a specific component, a specific software component in the stack to basically deliver that to the OEM for integration in the overall system. So the question is, what should the electronic tier ones do to make sure that they are not losing a significant share of their business and become the next computer manufacturers. In the 90s, we had a similar situation with computing hardware. There were companies like IBM, like DEC, like Sun Microsystems. They produced computers, workstations at scale, and they had that business. Everybody had his own operating system, everybody had his own applications. With the introduction of more standardized hardware and Linux, this business faded. And companies such as Sun, Microsystems or DEC do not exist anymore, and IBM has completely transformed their business model from a computing company to a service company. They provide now software services, software as a service, software as a product, and other consulting services, but basically no hardware anymore. So a complete new business model, and tier ones need to think about what they do in the same way. Semiconductor players strive towards full stack solutions, especially but not only for mission critical applications. We do see that with NVIDIA, the US player that provides CUDA systems, the software with Drive OS, and Drive IX, Drive AV, and they even work now together with companies like Daimler, providing the full box, the box that is directly assembled in the car together with the application, together with the ADAS applications. And other companies are out. The traditional tier ones do not make business anymore. Huawei Qualcomm has started a partnership with Veoneer to do basically the same, to go in ADAS and automated driving, but also in connectivity. And the same is true in China with Huawei. Huawei leverages its knowledge in communications for car-to-X communication. They build joint development partnerships regarding infotainment, ADAS, and zonal systems on chips for software stacks with other OEMs. If you look at NVIDIA, it also shows what it means, because NVIDIA scaled basically from a GPU designer to a provider of graphic cards, including direct sales to customers, circumventing previous partners. So companies that used to buy NVIDIA graphic cards are now skipped over, and NVIDIA sells. The same is even true for data centers. And remember, we're talking data centers on wheels in the car. Now here we talk about the back-end platforms. In the past, NVIDIA sold basically modules or chips that have been integrated. Now they offer fully integrated place and build their own supercomputer to be installed in data centers. And the tech giants are also strategically expanding their automotive presence. Google with Google Automotive Services, and a lot of companies like, for example, Volvo, GM, Renault, Nissan, Mitsubishi, they will switch to Android and Google Automotive Services. Fiat Chrysler PSA will use Android and a third-party app store, and only some of the German companies are going to develop that on their own with Android open source, but sometimes even together with Google. Microsoft is leveraging the trust they gained with automotive companies as a technology enabler. They exploit the automotive sector slowly in the cloud, but they also already have the Microsoft Connected Vehicle platform that is being used, for example, by Volkswagen or Renault Mitsubishi as a software stack for infotainment. And last but not least, Amazon going in with its Greengrass product that basically extends the technologies that are being used for software platforms to the backend. What does it mean for OEMs? They have the risk to be strategically dependent on a few semiconductor players and basically a foundry in the West and a foundry in the East. So they need to think about cooperations with more semiconductor companies and own ECMs, and they probably need to make sure that there is an own foundry in the EU, as China is doing and trying to achieve, to produce their own semiconductors in China to become less dependent on the Western world and the US. So what's the way forward for OEMs, tier ones, and software companies? We can support you with that. It's basically to define the strategy and to adapt the business model. Let me summarize the trends. The car is becoming a data center on wheels, with computing hardware centralized, consolidated, and commoditized, with profit pools that are shifting and players along the value chain that are repositioning themselves. Technology companies enter the automotive space with already scaled solutions. Engineering and electronics manufacturing service providers integrate vertically beyond build to print, as we can see it with Foxconn, that recently announced to offer a full driving platform for electric vehicles, including the software for propulsion, energy management, and the interfaces that can easily be integrated by OEMs. And Semco players not only offer the hardware and systems on chips, but also high-level software stacks. So traditional EE suppliers are under pressure from all sides. For the OEMs, shorter product and innovation cycles lead to further pressure to adapt their organizational structure, product life cycle, and their innovation roadmap. And both have to define their software and hardware strategy, the competitive position in the value chain, and their business. We are happy to discuss with you and contact us to get a copy of the presentation. I can also put you in contact with my Chinese colleagues, with Ron Zheng in Shanghai, from who heads our automotive practice in China, to discuss further. Thanks a lot.